Hi, everybody. Thanks for joining the session. Myself, Rajath, and today I have along with me Edward sharing in this session. Last year at IstioCon, we talked about how did we go about onboarding our entire infrastructure to Istio Mesh. This greatly helped achieve our reliability and observability goals. And in along with that, at Carousel, we have primary focus on improving the developer productivity and experience. In this session, we will be talking about what was our development environment setup, what were the gaps that we found out as we grew as a tech org, and what was the major solution and the goals that we wanted to achieve? How did Istio enable us achieve the goals, especially on the routing side of things? And lastly, how was this whole solution encapsulated into a usable tool across our organization? So to start with, we before we had the solution rolled out, the changes were being tested locally, and once it is good, it was moved on to the staging environment where we used to do like integration and validation tests. Once things look good, it goes to production. Let me explain with example. There is a feature one being developed that requires changes in service 1 and 2 on branch F1, and there is concurrently bug being fixed in a branch B1 for a service 1. These changes would were made in isolation and tested accordingly. Once done, like these changes were merged to a stage branch in their respective services and deployed onto a shared environment. And now the changes were tested, the flows were tested in the shared environment for the integration and validation test. Things look good, we go on to production. This worked quite well for us in the initial set of days, but as the team grew and the number of changes were also grew, we started to see the signs of that hampering our productivity and experiences. The top uh, 2 to 3 reasons would be when we are merging the changes into the stage branch, the changes would be not much properly, that making us not testing the actual change. The next one is when there are multiple changes being tested in a shared environment, when something fails, we are not sure which change, like feature one change or a bug fix one change that affected the actual uh, flow of a service one. And lastly, another use case is, let's say there is another feature three being worked on, and in that there is a service three being changed that has a dependency on service one. Because of the service one also being concurrently changed and it is unstable, that affects the delivery of the feature three as well. That is on the that blog that is being worked on the service three. So all these things essentially started to hamper our productivity and experience. And we thought a bit more about it, and we came up with a set of requirements on how would the ideal solution look like. The first and foremost thing is we wanted to test these changes in isolation, not affecting any other dependencies. And this not only is limited to a single service, but to a set of services. As in a microservice setup, when a feature is being developed, most of the times there'll be more than one service being tested or changed. So this environment should be able to uh, take like not only single service, but multiple services. And while this solution is being worked on, the major changes should be mostly on the platform side, requiring minimal changes or no changes on the microservices that are going to use this solution. And yeah, definitely we wanted to have this solution in a self-serve mode where the engineers are empowered and thus developer friendly. And lastly, the solution had to be cost effective. because having multiple environments concurrently running also would be a major concern on the cost. Before going on to the actual solutioning details, let me give you a high-level overview of our architecture in the perspective of how Istio is used. We use a shared control plane architecture where the entire control plane is deployed in a isolated Kubernetes cluster, and all the related artifacts are also Istio artifacts are also deployed in the same cluster, that is virtual service, destination rule, and sidecar. Mostly exists for almost all of our service. Workload entry and service entry are optionally used when there is use case. It has to talk to a component outside the Kubernetes cluster, probably data stores included into the mesh. And the request, the entry point to our whole mesh is the Istio ingress gateway, where the request from the client comes to our OpenResty servers. From there, it goes onto the gateway and routed to any of the services within the Kubernetes clusters. Within the Kubernetes clusters, yes. Going a bit more detail onto the setup, we had multiple namespaces where each namespace would be encapsulate all the deployments related to a given microservice. It is not only the application deployment, but also its worker, its cron jobs, and anything that comes in the purview of that particular service were deployed in that namespace. And in the control plane as well, we these CRD, the artifacts were applied to the specific deployment as required. One of the things probably I would want to highlight is we adopted namespace isolation using a sidecar that had greatly helped us optimize on the resource utilization on the control plane. Also provided some amount of optimization on data plane as well. Now, moving on to the approach, it was obvious from the beginning for us that we cannot create a complete microservice setup for testing out individual features or the bug fixes, which is not an ideal thing on cost as well as that time. Uh, and looking more into the detail as a requirement itself, we wanted to test the changes of a given feature that requires multiple services in isolation. So essentially, in other words, only services that were being changed had to be deployed in isolation and tested before getting into a stable stream. Let me explain it with an example. Without any changes, we have a stable environment. We can call it a staging for this discussion. And all the services here had a like prod container, which essentially is derived from the master branch, and they are quite stable. Now we want to develop feature one that requires changes in service one and two. We do it and we create a feature environment and deploy only the changed services in parallel. And whenever we want to test this particular feature, the request is made to the stable environment with the identifier of an environment. In this case, the request lands onto the gateway with identifier of feature one environment. So gateway should intelligently route the request to service one in in the feature one environment instead of the stable environment. And the service one in turn calls service two, and the rules or the intelligence that has to be built in again here is if there is a dependent service that is deployed locally within the developer environment, route the request locally. If not, then the request should be routed to the stable environment. In this example, service one has to talk to service two. It is routed locally, and service two has to talk to service three to complete the entire request loop. As it is not present within feature one environment, it routes the request to stable environment, completing the entire loop. The core problem that had to be solved is the intelligent routing, which was enabled by Istio. And how did we go about doing it? I would be handing over to Edward. Over to you, Edward.
Thank you, Rajath. Continuing from the approach set earlier, now let's see on how we deploy and also do the routing for our dev environment. Initially, we have only a stable environment where we deployed all our microservices there. In carousel use case, we deploy each our services in their own respective namespace. For example, here we have two services, service A and service B. We deploy service A in service A namespace and service B in the service B namespace. Now, whenever service A want to make a call to service B, simply service A can discover service B via svcb.svcb.svc.cluster.local domain that we set up via Kubernetes service. Generally, we have this simple virtual service where we capture the host name svcb.svcb and route the traffic to the same svcb.svcb service as the destination. Now, let's say there is an engineer want to add a new feature to the service B. In the on-demand dev environment, what he can do is to create a new environment. Let's call it feature X, and then he only need to deploy the SVCP there. Like this. But the different here, we deploy the service B in feature X namespace. Now, how can service A reach the service B in the feature X environment? So here we take our egress call from service A to service B with an extra header. Here we use C tenancy header as the tain or marker for a request where the request should be routed to. So for that, with the help of a virtual service, we insert this rule to match the C tenancy header with the value of the feature name, and then we route the traffic to the service in the feature environment on the feature namespace. Right. With that, in service A, there is not much changes, especially on how we make a call to A to B. The address is same, svb.svcb, but here we add an extra header on the C tenancy header. Now, in case of someone else want to update something on the service B, simply he can also create another feature environment and deploy it in the different namespace. And then our virtual service also need to be updated with one more measure to match the new environment tenancy header and also route the traffic to that namespace. So now let's see in the more complex use case. Here we have a flow, start from the service K, K then make a call to service L, L call M call N. So in the normal cases, we only have one this stable environment. Everything will stay in the stable environment. But then let's say we want to modify the service M, and then we deploy it in the different environment. Let's call it again the feature X as the environment name. Now, how we can utilize that service M in the feature X environment? To do that, we whenever we make a call to this flow, start from the beginning, we always inject the C tenancy header there and define where is the environment that we want to route the traffic to. Here, service K, since service K only available in the stable environment, service K in the stable environment will receive the request and then forward it to service L in the stable environment as well. Notice that the C tenancy header is also being forwarded to the service L. And now service L, whenever I want to make a call to service M, it also propagates the C tenancy header. If the C tenancy header is feature X, then the request will be routed to service M in the feature X environment. Otherwise, if the C tenancy header is undefined or we put any random value, we will use service M in the stable environment. And then next also, regardless service M in the feature X or in the stable environment, we always also forward the C tenancy header to the service N. Since the service N is not present in the feature X environment, we route the traffic to the service N in the stable environment. So to help us to propagate the header from start till end, we introduce a metadata or header propagation library where the app can capture some incoming headers, including the C tenancy header here, and then put it in the outgoing context whenever we want to make a call to other service. Here, we extend the trace context propagation, which also Istio mentioned in their documentation, to forward certain headers. In this case, for the trace context is the XB3 headers and few other tracing headers as well. So if we have that capability, probably we can also do the same for the C tenancy header. Next, moving on to the ingress. Since the C tenancy routing is the critical part here, then in the ingress is also we need to implement the same. We need to introduce the same C tenancy header routing in the ingress controller here. So with Istio, generally we configure the ingress routing via virtual service as well. So here our virtual service, we define where is the gateway that should route this traffic and what prefix. One thing here to simplify the route C tenancy header routing, here we use virtual service delegation. This way, it will simplify the config, and the delegated virtual service will have something similar that we have earlier, which to match the C tenancy header and route the traffic to the proper workload in the proper namespace based on the C tenancy header, and as a fallback, we will route the traffic to the stable environment here. Yeah, and then to improve on the maintainability as well, we notice the inter-service communication virtual service. We can also do the same. We can also delegate the routing portion into another virtual service. So ingress gateway and the normal virtual service, we can delegate the C tenancy header routing to a separate dedicated virtual service here to simplify our configuration. Yeah. Maybe you will notice one thing. How can we access web or the front end website from browser? Because we always need to inject the C tenancy header when we want to make a call to services or application in different environment. One approach to do that is via browser extension, which allow us to insert custom headers. But then it might not be available for the mobile browser, since it's not allowed to install any plugin at the moment. So for that, we have some workaround, which is we use custom DNS domain. Here we have star.api.carouseltenancy.com for our API endpoint, and star.www.carouseltenancy.com for our website front end endpoint. So the first portion is actually the tenancy name. So Istio allow us to have a simple Lua script. There we deploy our envoy filter, which basically to capture the host name and then take the first part of the host name and then put it as the C tenancy header. This way, we will have quite seamless flow. Now, if we deploy this, we can access our website from the any mobile or desktop browser without having to inject the C tenancy header via the extension. So just purely access, for example, featurex.www.carouseltenancy.com directly. And here, good thing that major DNS provider allow us to use wildcard DNS. That way, we can set up star.api.carouseltenancy.com and then point it to the external load balancer IP. Same for the star.www.carouseltenancy.com. We just need to point to the same external load balancer IP. So with this setup, we don't need to create every dev environment or the tenancy name DNS record all the time. Yeah. Next, here we want to give some summary on overall how we set up our dev environment. So here on our dev environment, we only need to deploy the required workload, which have some changes in a dedicated or a separate environment or namespace. And then with the help of the virtual service, we do the tenancy routing via specific header. Here in Carousel, we use C tenancy as the header name. And then our services or our app need to implement the header forwarding, which to forward the C tenancy header from incoming context to the outgoing context. And then last is on the ingress gateway and also the normal virtual service. We can delegate the C tenancy header routing via a delegated virtual service to enable us to make us easier on the maintainability of the virtual service. A couple of tips or recommendation is to use the wildcard domains for our each entry point. So here we prefer star.api.carouseltenancy.com or star.www.carouseltenancy.com rather than the API or www.featurename.carouseltenancy.com. Why? Because with the first format, we can set up a wildcard SSL certificate as well. So because setting up the SSL certificate may take some time, and also we can have a wildcard DNS entries as well. So all the domain and the SSL is pre-set up earlier, so people just need to use the people can access the dev environment directly. And then to help that, yeah, we deploy the envoy filter to capture the tenancy name from the domain that we use. Second recommendation, we also use Istio namespace isolation, basically to improve the performance of our control plane and data plane, so that they will have only few destination cluster on their sidecar setup. And then for the rollout and the tooling, in Carousel we write our own in-house CLI tool to manage the virtual services. And then we integrate that our in-house CLI tool in our Jenkins, so that engineers can trigger or create the environment on their own, and also they can also destroy the environment that they already use for their development purpose. Also for make the experience of the developer more smooth, basically we also have a Slack deployment bot which they can invoke /feature deploy to deploy and /feature destroy to destroy and feature environment. Yeah, and one last tools that we have is to automatically clean up the inactive environments, because although we already have the feature, I mean the job to destroy the existing environment, people may forget to destroy it. So we automatically clean up any environments that created older than 1 month. And to improve this, actually, we are thinking to destroy all the feature environments which has no active deployment in past say 2 weeks as our sprint window. Yeah, till here our and we can, yeah, with the our dev environment setup, we see a great improvement on our staging stability, as we only deploy the stable release there, and also lesser changes happen on the staging environment, and no lesser conflict that happen on the developer side as well. That way, we also see a lot of improvement on the developer productivity as well. Yeah. Till here is not complete. Everything is not complete, although we see a lot of improvement there. There are still a few more things that we want to do, and we already see that in line. Couple of them is config management for the dev environment. As of now, we utilize the console as our key value config, where we store our key value config, but it is shared with the stable environment. So with that, we want to make the configuration at least immutable with the config map, so that each dev environment can have their own configuration based on the stable config. And the second improvement is we want to have a context-aware data store. Here, either we contain the data for a specific feature environment, or even we can also have a dedicated table or database or different cache for different dev environment. Yeah, I think that's all that we can share about on-demand dev environment. If there is any further questions regarding to that, please feel free to reach us on the discussion channel, or can also directly contact us in our LinkedIn here. Yeah, yeah. I think at the end, we want to say thank you for everyone who joined this session.